In the previous chapter, we have seen characteristic relationships in action through attribute lookup. However, it is not very flexible as the attributes and target info objects must be the same. There are many instances where we need to perform much more complex characteristic relationships, such as the case we find ourselves in where the info objects do not agree, or even where we need to perform data mining of historical combinations to determine the most appropriate value. In this chapter, we will have a first look at the AMDPs, or ABAP Managed Database Procedures. An AMDP allows developers to write database procedures directly in ABAP. You can think of a database procedure as a function stored and executed in the database. The implementation language varies from one database system to another. In SAP HANA, it is SQL script. Using AMDPs allow developers to create and execute those database procedures in the ABAP environment using ABAP methods and ABAP data types. There are several steps in creating an AMDP for characteristic relationships, and we will cover each of these steps in this lecture. We will also move the attribute lookup to our AMDP class for illustration purposes. So the first step is to create an ABAP class as a container for the SQL script. And this class must inherit from the class CL, RSPLS, CR exit base. Now I've already created the class as you can see, but let me show you how to create a class. So you go to your ABAP project, and on the package you right click, it's a new ABAP class. You simply give it a name and description and then finish. You will then be presented with an empty class, and you can simply cut and paste the code from the manual. Next, we need to assign the interfaces to the class, and there's two interfaces. The first one is IF, RS, PLS, CR exit HDB, and the marker HDB. These interfaces will make the required methods available to our class. Next, we create the ABAP types for the characteristic relationship. The types consist of all the source and target characteristics of the characteristic relationship step. In our case, it consists of 3 fields. And the fields are material, material group, and unit. So material is the source field, material group and unit are the target fields, so the fields to derive. Next, we're going to create our methods. We must create 2 methods, a SQL implementation that will contain the main logic for a characteristic relationship, and an ABAP implementation that will run when manual data is saved. The ABAP implementation, and if we look at the definition of the method, is a redefinition of interface IF, RSPLS, CR methods derive. This method is called when we save data through analysis for Office. We cannot change this, unfortunately, and then execution is called for each row saved. Unlike the repost on basis of characteristic relationships planning function, which processes all the records in a single execution. So first, the SQL method. The definition of the method is as follows. It contains 2 tables, an import and an export table, both of the same type, and it is unlikely that they will be different. Next to the implementation. An AMDP method is indicated as such by the addition of the byte database procedure addition of the method statement. At the same time, the database platform and the programming language used to implement the method are respectively specified by the additions of for and language. Further additions are also available. You also need to specify which database entities are used in the method. In this case, the master data view of the info object 0 material is used, and you can specify additional tables as well. The SQL implementation is as follows. It reads the import table, the material from the import table, and then derive the material group and the base units of measure from the master data view of the 0 material info object. You can simply copy this code into your method. Next is the implementation of the ABAP fallback method. Since we don't want to rewrite the code in ABAP, we simply call the AMDP procedure we just created. This requires less maintenance as the types and code is reused. The method definition is as follows, and again you can copy the code into your method. We need to declare each of the AMDP methods in the getSQL script info method as follows. And this is only required for the amdp methods we created. The next step is to create the characteristic relationship in RSPlan. I'm in the info provider view of transaction RSPlan where we created our previous characteristic relationship, and I'm simply going to change this characteristic relationship type to exit and select the class we just created. Then I assign material as a source characteristic and material group and unit as target characteristics. Activating the class is not enough, as this does not create the stored procedure in HANA. We need one more step to make this work, and that is to create an ABAP program to call the method and create the procedure. This program is also very useful to test the amdp class, since we can add test data to it. So I'm in transaction SE38, and I'm going to create the test program. So that's my program name, create. It's going to be CR test. The type is an executable program, and the status is a test program. So I'm going to save it and paste my code in. Now we see that we reference our class to get our types. I first select test data from my volumes planning ADSO, and then we need to source or define the source and target characteristics, and this must be in alphabetical order. So I say which is source and which is target characteristics. Or I initialize my class and then I call my methods. So after I've activated, I can put in a breakpoint and execute. If I step over, you can see that it's executing my SQL code. And when I go to tchaz, we should see the values of material group and unit having been derived. Now let's look at our planned volumes by material group query. We know that we've got material group and unit of measure, and if we look at the extended settings for material group and unit of measure, we see that they're all on characteristic relationships, while our sales org is on master data as well as our fiscal year period. Now let's resume where we left off in the previous chapter. In the previous chapter, when we attempted to plan against the material with no postings, we could not, because the unit of measure was not derived, thus not giving us a unique intersection for that key figure. After our work now, we can see that unit of measure as well as material group has been derived by amdp, and we can plan a record against that key figure. In this chapter, we created an amdp to perform two tasks. Derive the correct values from master data using SQL script in order to repost the existing values in the ADSO. This is useful when attribute values change. And create valid combinations for the input-ready query by using ABAP for HANA. We are making good progress in creating the planning application, but we are not yet ready to calculate the revenues. Volume data is still only on material level. In the next chapter, we will perform a top-down distribution of volumes to customer. Since we are on the topic of top-down distributions, we will also look at top-down distribution functionality available in planning-enabled queries.